Good day, everyone. Thank you again for joining us for the Women in Data Science Trinidad and Tobago Datathon Workshop Series. I am Dr. Leticia Addison. I am the ambassador of, as we call it for short, WiDS TT. And today we start off with our first Datathon workshop for 2025, entitled Getting Started with Data Exploration, the WiDS Global Datathon. Thank you all for joining us. Let's jump right in. For those of you who are new here, let me just give you a little bit of a perspective into what WiDS, or Women in Data Science, the global organization, does. We elevate women in data science globally through various modes of support, including conferences, datathons, podcasts, WiDS Next Gen workshops, and we also do a lot of other outreach within our local communities. We have a lot of countries worldwide who participate in the Datathon and also have their own local organizations. So in terms of Trinidad and Tobago, we have our own organization that actually matches up to the values of the WiDS Global organization. Now, in terms of how it started in Stanford University in 2015. It actually started first as a one-day conference, and it has grown tremendously over the years with more than 200 regional events worldwide and more than 100,000 participants. So every year there is a WiDS Global Datathon Challenge. Now, although, as you can see, the word is Women in Data Science, just note that we are very inclusive and we do feature women in our events and females. However, all of these events are open to all genders. Now, the actual WiDS Datathon is a data challenge which helps to inspire persons who are in the field or who are motivated to get into the data field to understand how to use data science for good. This year's challenge is based on brain health. So if you would like to sign up for this challenge, you can actually go to the website for the WiDS Worldwide Datathon Challenge, where you could see the website here, and we'll also share those details for you in the chat. And this challenge runs from January to April this year, and it's based on unraveling the mysteries of the female brain. Now, our mentors today will actually give you an insight and an in-depth look into how you can access the data for this challenge, for those of you who are interested in entering the challenge in teams. And for those of you who probably just want to see what it's about or really understand, that's okay. We welcome everyone who just has an interest to understand what data science is and how you can use it. So you can actually read more about the challenge on the website and get an insight into what it's about, really looking at this year with the brain health and different aspects of the demographics involving women's brains. For those of you who also would like to think about entering the challenge, we would also want to tell you that we have some events, not only from WiDS Trinidad and Tobago, but also other Datathon workshop and events that happen from other spaces in the globe. And in terms of the challenge itself, you will be able to hear more about it in terms of the types of teams that you can build, 1 to 4 persons per team, with at least half being female. And throughout this process, you can have access to mentors, workshops, and other events. And also there are some prizes that are available on the platform where the challenge is hosted, called Kaggle. And this is really a great opportunity for persons to sort of network and interact with others for a good cause. Now, as we mentioned before, WiDS Trinidad and Tobago hosts Datathon workshops and regional events. We really do independent events, both online and in person, to really support the Datathon Challenge globally and to also support you in your own journey wherever you are in terms of understanding how to use data science. Of course, you are aware, some of you would have been aware of the Datathon workshop series that we host. We have been hosting these for the past 3 years. And we also host spotlight events in terms of speakers, also fireside chats, and other really fun events, also secondary schools for high school students and students who would like to get into the field. If you would like more information on that, we will post the website in the chat for you. It's widstt.com. and you'll be able to go there and actually find out more about our events. And this is just for persons who are interested specifically in the challenge. Now, I'm just putting this snapshot here. Don't worry if you miss the information now. Our mentors will walk you through it. If you're really interested in entering the challenge specifically for this purpose, you can go on to the page kaggle.com/competition/WiDS Datathon 2025 and see what it's about. To actually register for the challenge, however, you may also need to go to the widsconference.org page, which is the global page, and indicate your interest in entering the challenge there. If you would need any support from us and our teams and would like to join any of our teams eventually, feel free to reach out to us. So we have our own call for participants and mentors on our page as well. And if you have any specific questions, do not hesitate to contact us via email at widsttgroup@gmail.com. Also, a new addition this year, we have a community platform, which is part of the global platform. Some of you who were here last few years would have known we would have probably used other channels involving Slack. This year, WiDS Worldwide has its own community platform, which is really an amazing space for you to connect with not only us, but other communities around the globe and see what events are happening. So I would encourage you to join. The link is below. It's a little bit long, but if you're interested in joining, reach out to us via email and we can put you on that list so you could actually be part of the community and interact with others there as well. Now, we're not going to go through a whole in-depth overview of data science today for this specific workshop. However, we do have some really fun content on our YouTube page. So I'm just going to mention the behind the scenes of what data science involves before you get into this more interactive workshop to kind of guide you. Of course, it has origins in math, statistics, and computer science. And for all of you who have been hearing the buzzwords like artificial intelligence, machine learning, Internet of Things, you know that data science is actually a subset there where you would actually use things like machine learning, which has algorithms or instructions to learn from your data. And then the data science itself has a cycle of thinking about cleaning the data, analyzing the data, visualizing, modeling the data, and then giving those insights that you would want to give back to your communities. So if you want to get more information on data science and really hear about it in terms of how it's used in the real world and how it's actually used for the benefit of others, feel free to check out our YouTube playlist where we have some very basic videos that actually go more in depth into data science on the whole and how to get started in the field in terms of careers, etc. And you can feel free, we'll put the YouTube channel in the Slack for you so you can actually subscribe, like, and share with your friends and see when our new content comes up. For those of you who have joined late, just letting you know that our recorded content for these videos would also be on our YouTube channel for those of you who want to go back and play them. So the main event today and what you all are here for, and I am so excited to introduce our speakers who are going to talk to you today about getting started with data exploration in terms of this Global Datathon challenge. So we have three main people in our workshop team today. I'm really happy to introduce each of them, and they will give you a little bit of a perspective about themselves. Miss Leslie-Ann Jurawan. Leslie-Ann, actually, fun fact, she was always involved in looking at our videos like some of you, and then now she joined our team, and she's a really great contributor and mentor for these workshops. So we're happy to have her on board for the first time. We have our returning mentor, Miss Malini Rambaran. Miss Malini Rambaran has been with us for about 2 years, and she has always been involved in creating content and delivering content. And also Mr. Nicholas Smith, who is right there in the chat with you all, and he is really an amazing content creator when it comes to our notebook content and guidance. So I will just give the floor now to each of them. I'm going to stop sharing. So Leslie-Ann, Malini, and Nicholas, let's start with Leslie-Ann. Could you just come on and give them a little bit of your background? And you all feel free to ask questions in the chat. This is a very nice interactive session. So Leslie-Ann, I throw the floor over to you.
Hi, everyone. Can you see me okay?
Yes, we can.
Great. So I'm Leslie Angerawan, and a WIDS volunteer contributor. So I love finding ways to make data engaging. So I'm thrilled to be part of the workshop today. My path to data science started with a degree from the University of Waterloo in mathematical science. And through data analysis, I became interested in machine learning. But prior to data science, I worked in education and the cocoa and chocolate sector. So I'm always happy to hear about how people got into data science. So feel free to drop me a line anytime. Looking forward to today. Thanks.
Thank you so much for that, Lesbia. And now we head over to Malini. Malini.
Hi everyone, my name is Malini Rambaran. I am a WiDS mentor. I've been mentoring since 2024. A little bit of background about myself. So I have a bachelor's in computer science, a master's in data science, and I am a digital transformation consultant where I get to integrate my data science background. So that is really interesting, and I'm also involved not only with WiDS but with TT Lab as well, and it really helps me explore, the different fields and the new and emerging technologies.
Thank you for that, Malini. And just to let you all know what TT Lab is actually our local data science group. So a lot of our mentors who work on real world problems, we actually have them also work, well, they actually work in TT Lab doing that research as well. And I'll put that link for you all in the chat so you can see what TT Lab does. And next we have Nicholas. So thanks, Malini. Nicholas, I know you're not on video, but you can come on and give them a little bit of your background.
Sure, no problem. Can you hear me?
Yes.
All right. Hi, everybody. My name is Nicholas Smith. I graduated with a bachelor's in computer science. I am currently working on software engineering contracts. So my main background is software engineering, but I do also have a passion for continuous learning, which led me to data science and machine learning. So as a volunteer, I contribute to creating notebooks and helping develop the content. And I also delivered an interactive tutorial on exploratory data analysis, I believe in the year 2022, 2023. And I've been a part of it from since then. And these experiences usually reflect on my commitment to mentorship, teamwork, and analytical problem solving. So it's great to have these workshops to help introduce everybody, your people, to data science and get them involved. So thanks a lot for being here and hope you'll have a great time.
Thanks for that, Nicholas. And I forgot to mention that our mentors, majority of our mentors actually have been participants in the Datathon and have won prizes in our local leaderboards. So they are really champs in their own right, and it will definitely help you all along in whatever guidance that you need. So thank you everyone for being here. Let us get started. So I'm going to throw everything back to Leslie Ann. She's going to start you off with giving you a background in terms of the exploration of the data, what exactly this challenge is about this year. And then Malini is going to come in afterwards in the second hour where she's going to go through the interactive notebook. If anybody did not receive the materials via email yet, if in case you registered late, feel free to let us know. We'll drop the link for you. All the materials you need for today are going to be in a folder. So Leslie, and I pass it on to you, and the link is in the chat.
Okay, thanks very much. Hopefully everybody can see me. I'm going to share my screen now. Let me know if you can see these slides and me. If you get any slowdown, I'll turn off my camera at some point.
We can
Just
see
let
the
me...
slides. Great.
Okay, great. Thank you. So today we're I'm going to be leading you through the first session of our workshop and the second one. This is what our agenda looks like. First, I'm going to be introducing you to the Datathon on Kaggle, and then go into more about the challenge itself. So first of all, how do you sign up for the Datathon? Before we start, I wanted to ask you about how familiar are you with Kaggle? Have you ever heard of it? Have you used it? So I'd like you to take a little poll for me now. Here's a QR code that you can scan to get to the poll. There's also a link that I think Heidi will put in the chat for us now. So you can either click on the link or scan this QR code. I'll leave it up here for 10 seconds. And then I'm going to go to the poll page, which asks you just click the answer that says how familiar you are with Kaggle. I'll switch that in 10 seconds. Okay. Great. So here we are, giving it about 10 more seconds just to see what the results are. I'm just going to switch to this screen in case anybody wants to use this code up here. If you can't get in another way. Okay, so it looks like it's holding strong at heard of it, never used it. Great. So this will be hopefully of great use to most of the people in this section here. And occasional users, I hope this encourages you to use Kaggle more. And our regular Kagglers, please feel free to give me any feedback at the end. I'm happy to hear it. Okay, so I'm just going to go back to our presentation now. Thanks very much for answering in the poll. Okay, back to the slideshow. Can everyone see the screen?
Yes.
Thank you. So first of all, what is Kaggle? To me, Kaggle is like a Facebook for data scientists because it's a place, a platform that data science enthusiasts can solve real-life problems, write and share code, host data sets, interact with their community, and compete in machine learning contests to win prizes. So you would have heard about that earlier from Dr. Addison, that there are global prizes, and also we're keeping track of the leaderboard locally, so you could win. I'll speed through this slide here because you would have heard Dr. Addison talk about the sign-up roadmap then. You need to have a Kaggle account. This is why we're going through Kaggle part now, to gain access to the competition. Using that Kaggle username, you have to register through the Global WiDS Datathon form to be part of the competition. And then you should also register through the widstt form so we can track local winners. And I'm going to show you now how to register. You just log on to kaggle.com, and if it's your first time, you should see options to register with Google, or you can register up here. Registering with Google, I think, is just faster, so I recommend that. And here are just some links so that you don't have to go looking for them. When you get these slides will be shared with you. So if you click on this green button, you'll get the links down here to go register for the Global Datathon. And the red button will take you to the widstt form and answer some questions like Dr. Addison told you about. So the links are there. And she also told you about the WiDS Worldwide platform, going there, joining the community, and then it'll take you to all that great stuff that she talked about. And you'll also be able to join the Trinidad and Tobago group as well. And get special messages directly from Dr. Addison and feel very special. So after you register, make sure you get an email that confirms that. And because the challenge is now live, you should get an email also that will have a link to go directly to Kaggle, to the Datathon on Kaggle, right? And it'll look like this. And it'll have an overview with a timeline that's very general. So I put in these dates here for you to tell you that the competition started on January 7th. You have to submit on April 30th, and you have until April 27th to merge your teams. If you don't know what that means, don't worry about it. We're going to talk about it now. And to join the competition, you actually click this button up here, this black button, join competition, and then accept the terms, and then the button will change. And I'd like to show you how it changes by going onto Kaggle right now. So I'm switching to the Kaggle site now. Hopefully you can see it. Can everybody see the Kaggle page? Hopefully. Okay,
Yes.
thank you. So I already joined the datathon. So the button has changed to submit prediction. I'll show you that in a second there. Here's the timeline I talked about. We have roughly 3 months to go. So you have all the information you need about Datathon on this page on Kaggle, right? So with Datathon 2025, you have all of these tabs with a lot of information. So first of all, the overview. I'm going to go through this background with you in session 2. But I just want to show you how you can navigate by yourself. You can go through this table of contents to jump to any section, talk about team formation. Teams of up to 4, at least half of each team must be individuals who identify as women. You can read more about that. I just want to point out the tutorials and resources section. It's a lot of really nicely curated information here for you. And also the global Datathon workshops that just concluded this month. The links are all here and their notebooks are here. Okay, so next I want to show you the data tab. Switch to the data tab. All this data set, this description. Again, I'm going to go through that with you. Don't worry about it. So I just wanted to point out, for those of you who are looking for something called a data dictionary, it's down here. You can look here to get information about all the variables that you have in your data sets. For those of you that are looking for it, these are the variables you'll be dealing with and where they come from, how you got them, and stuff like that. So you can also get an example of what your submission should look like. Here's the sample file. It should look like just a column of participants and 2 outcome variables, which we'll talk about later. Don't worry about it right now. But when you prepare this submission file, you just click Submit Prediction. Something like this pops up. Drag your file over here or browse your computer, and then click Submit at the bottom. And then you've entered. And then you'll show up on the leaderboard somewhere. You can see how people are doing and their scores. So if you go to code, you can also see some notebooks that other people have made public to help you get started. It's really interesting. But if you'd like to start a new notebook, you come up here to New Notebook and click on that. So this opens a new notebook, the random name, change it to something you like. You'll see on the top right-hand side, draft session off, run a cell to start. So by running a cell, they mean pressing the play button over here on the left side. I'm going to click it now. And what this does is it pulls in the files that you need for the competition. So we see draft session starting, and we see this spinning icon here telling us that it's doing what we want it to do. Takes a little bit because there's a lot of files. And when it's done, you'll see a little right. So here we have all the files that are pulled in. And then you can start working on it. So if, however, you want to work with your team in Google Colab, you can come up here to File on the top left-hand corner, come down to Open in Colab. Okay, and then you'll get this pre-generated code for you. So it also has some code to read in your files. But if I run this now, and it says gives you a warning about not authorized by Google, but that's okay. Click run anyway. So if I try to run this, I'm going to get an error, right? So the reason is that some Kaggle data sources are private, so we need to run this cell over here. which will ask us for a username and a token. What this is asking for is for us to create an API token. So you click here and you'll go to your settings page. I don't want to do it now because you need to keep your account number and API key secret. So I made a little video. I'm going to switch the video now. So can I get a confirmation that you can see this window as well?
Yes.
Thank you. So on the top right of the Kaggle page, you click on your beautiful picture here. And what you'll have is a little menu. Come down to settings. When you click on settings, you'll come here to this page, scroll down till you get to the API section and click on create new token. Whoops, sorry. So the create new token section here will create the token that you need, and a file will be able for you to download. And then you can extract the token and your username from there and put it into your notebook. And then you'll be able to run as usual. Okay, so going back to the slides now. So just a reminder, all these steps are in the slides as well, and will be available through the recordings. So you can follow either way you're comfortable with. So once you get your notebook running, you can share it with your team using the share button, just in the same way that you would share a Google Doc or Sheet or something like that. So one thing I want to point out is in the Kaggle sidebar, there's a learn section with a lot of really nice resources. Anything you're like not sure about, or it's the first time you heard of it, you can come here and get a really nice introduction to it. Hands-on little exercises too. So I encourage you to check that out. If, like me, you're scared to start your first competition without knowing exactly what to do, they have a Kaggle for that. You can go to something called the Titanic Machine Learning Titanic dataset, which is machine learning from disaster. This is everyone's so-called first competition. It's made simply for you to understand how to enter competitions and what that process is like. It's very quick, so I encourage you to check it out. And with that, we are done with session 1, and I'd like to go on to session 2. So if everybody could put a little emoji in the chat, a little smiley emoji, let me know you're okay and ready to go on.
If anyone has any
Okay.
questions, please feel free to put them in the chat as well.
Okay, so if there's any questions, please let me know and someone else will answer it. Okay, so if that's okay, I'm going to go ahead with the section 2. Okay, so in section 2, the focus is on the Datathon challenge itself. So what we want to do is answer some questions. First of all, what is the question we are trying to answer? What do we need to answer that question? And what data do we have to accomplish our task? So to explore these, we're going to watch the Datathon, the official WiDS Datathon 2025 video. And as you watch, try to identify the challenge question, the task, and why it's important. Okay, so let's watch the video now.
The male body has been standard since always. Lab rats, male. Clinical test subjects, men. The tenured neuroscience faculty, 80% tweed elbow patches. But what if? What if? Maybe. What if we set fire to the status quo? Demand better, broader data. Study women. Thousands of them. We start a revolution in neuroscience. or join those who already have.
Join us for the 8th annual WiDS Datathon. We created the WiDS Datathons to solve social challenges with data science approaches. WiDS provides a supportive environment for everyone to connect, learn from each other, and have a lot of fun. We're excited to partner with Ann S. Bauer's Women's Brain Health Initiative in collaboration with Cornell University and UC Santa Barbara to bring you this year's challenge.
Attention deficit hyperactivity disorder, or ADHD, occurs in about 11% of adolescents, with about 14% of boys and 80% of girls having a diagnosis. There is some evidence that girls with ADHD can go undiagnosed, as they tend to have more inattentive symptoms, which are harder to detect. Girls with ADHD who are undiagnosed will have continued suffering symptoms that are a great burden to their functioning and mental health. In the Global Datathon, challenge participants will be tasked with building predictive models based on measures of individuals' brains to diagnose adolescent ADHD. Tools of this nature can actually help us identify individuals who may be at risk of ADHD, and importantly, to help shed light on the parts of the brain relevant to ADHD in boys and girls, which in turn could lead to improvements in personalized medicine and therapies.
For this challenge, we will look at diagnostic data and functional magnetic resonance imaging data from the Healthy Brain Network, or HBN, which is the signature scientific initiative of the China Institute. HBN utilizes a community-referred recruitment model by encouraging the participation of families who have concerns about mental health or learning challenges in their children. HBN offers no-cost diagnostic evaluations to participating families. HBN also supports and promotes open science by sharing all multimodal datasets collected, including phenotypic, magnetic resonance imaging, and electroencephalography data. Functional connectivity maps used in this challenge represent the functional connections between different regions in the human brain.
Sign up now for the 2025 WiDS Datathon.
Okay, that's that.
The male body has been
All right, so were you able to hear the challenge question and task? So the challenge question is, what brain activity patterns are associated with ADHD? Are they different between males and females? If so, how? Our task is to build a model to predict ADHD diagnosis and a second variable, second target. Did you hear it? It's the sex, the gender, male or female participant. We're going to do that using brain imaging data of children and adolescents and their socio-demographic and emotional and parenting information. We'll learn about that later. And why is it important? It's important because we're hoping to identify those at risk of ADHD, which is difficult to diagnose in, according to the video, females. We're hoping that these results can be used to improve personalized medicine and therapies and improve the mental health of affected individuals. So say hello to Widsy. Widsy is going to help us understand this data because it's pretty wordy and dense. So Widsy is an adolescent whose parents were encouraged to take advantage of the free evaluation for mental health for their child and take part in the Healthy Brain Network study by answering some questionnaires and having her undergo an fMRI scan. So you probably know what MRI stands for. Maybe you heard at some point that it means magnetic resonance imaging. But what does the F mean in fMRI? Does it mean A, frontal, B, formative, C, functional, or D, framework? So if you want, you can type the letter that you think it is in the chat and let us know. Type A, B, C, or D. Ready? Go. Anybody else want to try? Okay, 5, 4, 3, 2, 1.5, 1. Thank you very much, everybody, for trying a guess. If you guessed B, not B, sorry. Let's check the answer. If you guessed C, answer is C for functional MRI, functional magnetic resonance imaging. So it's long to say, so you might often hear fMRI. So what that is a type of MRI scan that shows the parts of the brain that are working hardest or functioning hardest by appearing brighter in the scan. So how does it do that? So it uses a normal MRI machine you might have seen before by tracking the blood flow in the different parts of the brain. And the blood flow shows the areas of the brain that are working hardest. As I said, they're appearing bright on the fMRI scan. And in Widsy's case, she's asked to just lie in the machine, not do any task or anything like that, because we're taking a reading of the brain at rest state. Okay? So how do we know parts of the brain are working together? So it has to do with the blood flow, like we said, and the active areas. And by active areas, we mean the blood that's flowing in 2 areas at the same time. So if A and B are both active, in that way, blood is flowing between them. Blood is flowing in those areas at the same time, sorry. Then we can say that they're probably connected or at least working together. So we can think about the brain connectivity like a map, like a Google map. So in the same way that a city is connected by roads on a map, the brain can also be mapped out as well in terms of the connections. So we call that brain map a connectome. And so anytime you hear the word connectome, just think brain map. And it's built by tracking the patterns of blood flow in the fMRI scans. So it's very important for scientists to study brain connectivity to understand learning, how memory works, and origin and treatment of mental health conditions. So I have a couple of videos here for you just to visualize what it is that you're going to be studying, and gives you a real, like, visual understanding of what you're seeing in the data. So you can feel free to access these through the slides, and they'll be available for you. So how do we get this information into the data set? The brain is divided into regions of interest, and the average activity of each region over time is extracted into this regional time series. And then that information is used to create some kind of 2D functional connectome matrix. Now, this is a super, super, super simplified example I pulled in here just so we can visualize what we're talking about. We have the regional time series. Correlation between any 2 brain regions time series is represented like this. So let's say region B and region A, they get a score of 0.6. And we can interpret that as the larger the positive values, we can say the regions have more similar time series, so they can be seen as having a stronger functional connectivity. Wow, that's a lot. So let's say hi to Widsy again, getting stressed out. According to this goal of the 2025 Datathon, we want to predict for Widsy and a couple thousand of our friends. We would like to predict two things using the functional connector matrices we just talked about. To build a multi-outcome model, meaning two outcome variables here, we want to predict whether there's an ADHD diagnosis of that participant and whether that participant is male or female. So I want to talk about the data specifically now, and you can access all of this on Kaggle itself using this link in the slides. About the dataset itself, the Healthy Brain Network dataset, there's about 1,500 plus participants. So that's like 1,500 rows of data, you can think of it as. And there's information about each participant's emotional well-being, their behavior, their parents answer questionnaires about their parenting. And you have the functional connectivity network matrix we talked about. And for each individual, additional biometric data like the gender, ethnicity, race, etc. And the data set will come in two folders, a training set and a test set. And they'll both have the variables I just told you about, the fMRI connector matrices, and some quantitative and categorical metadata, the ones I just told you about. But the train data, the training file, will have the variables, the targets, the ADHD diagnosis and sex variables for you to train on, and they're not in the test because that's what we need to predict. So speaking of which, this is the form they'll take. They're two binary variables. So either it's a 0 for there's no diagnosis of ADHD or some other diagnosis. 1 if ADHD was diagnosed. 0 for male and 1 for female. So the participants were given an ID. So let's say Widsy has her participant ID here. She went to the Midtown test location and they stored that as a category 3. They also stored her ethnicity and race as categories as well. And some quantitative data, like she was 10 3/4 at the time of the MRI scan. She enrolled in 2019. She has a color vision test score of 60.03 and a handedness score of 14. What that means is that this is a score for her color perception test, and this one is a score for her dominant hand score. In the variables, you might see it labeled as EHQ, which stands for Edinburgh Handedness Questionnaire. And then let's meet the parents. Each of the parents of the participants in the study, each of the participants' parents in the study were asked about their education level and their occupation. So Widsy's dad, for example, he was a high school graduate, and so he got a category 12. That was what was entered. And the mom got a category 21 assigned for her graduate degree, and 45 for her job as a professor. So all of these were part of something called the Barrett Simplified Measure of Social Status, which is a measure of social status and a proxy for socioeconomic status. The parents were asked a bunch of questions measuring different domains of parenting, whether they beat the child or whether they don't, but it's a score, not just yes or no. So that gets different scores based on the discipline and the type of parenting. And this particular questionnaire is called the Alabama Parenting Questionnaire Parent Report, APQ. So you'll see these scores under variables that start with APQ at the start. And then they were also asked some behavioral questions about psychological attributes, about Widsy's conduct and emotional problems, that kind of thing. And this is called the Strengths and Difficulties Questionnaire, SDQ. So you'll see those variables, those scores stored in variables that start with the name SDQ. So most of the variables are kind of understandable. You can guess what conduct problems and emotional problems scores would pertain to. But these four, I thought, let's just talk about these in a little more detail. So generating impact measures how much identified difficulties interfere with day-to-day functioning. Hyperactivity scale, that reflects inappropriate levels of inattention, hyperactivity, and impulsivity. The internalizing score reflects emotional or mood problems, and the externalizing score reflects dysregulations in behavior, including conduct problems, aggressive and rule-breaking behavior. Just so we can think a little deeper, here are using these numbers here and these pictures here, try and match the variable to the picture. Match the picture to the variable. So for example, here's picture A, picture B, picture C, and picture D. If you think that definitions 1, 2, 3, and 4 match A, B, C, D pictures in that order, please type A, B, C, D in one line in the chat now. Thank you. I'll give you some hints. Number 1, day-to-day functioning. Look for something that has to do with your day-to-day life, like your home life, your friends, your school, your hyperactivity. Look for something that has to do with your attention, hyperactivity, your internalizing score, emotional and mood problems, things that happen within your own mind, and externalizing score, behavior and aggressive looking people. All right, anybody else wants to try? Five, 4, 3, 2, 1. Okay, the answers are 1 goes with C. Thanks to everybody who answered. If you answered C, A, C, D, A, B, then you are right. Generating impact, you can see the picture there has to do with the day-to-day negotiating relationships with friends and school and at home. Hyperactivity, ADHD, I did not mention up till this point, stands for attention deficit hyperactivity disorder, just to make sure that we know the meaning of that, because we do throw around ADHD a lot these days without talking about what it stands for. And internalizing, those are all internal kind of mood-related pictures. And the next one, B, has to do with aggression and rule-breaking behavior. So thanks for answering, everybody. I go at the next slides go further into detail about each of these definitions, and also maybe a way to interpret high positive scores and low scores or negative scores in the data. So those are in the slides, so feel free to check those out. Moving on to maybe the most important part of this data set is the columns of connectome data per participant. You're going to open up and find a bunch of columns that look like this. And to help you understand what it might mean, let's pretend row 0 is Widsy, and she would have all of these columns of data, a lot of columns. And we can think of each number denoting the strength or density of connection between two regions. So let's say this one is between region X and region Y. And this section here is for maybe region X and Z. So we come up with 19,900 columns of connectome data per participant. If you're interested in how you got that, you can check out this slide later. If you're not interested, you don't have to listen to this part. Basically, a very simplified version of what's happening is from that connectome matrix, since it's symmetrical along the diagonal, we basically just throw away the lower portion, including the diagonal, left with this, and then we flatten this out to make a vector of 19,900. And I'll leave that right there because don't think about it too hard right now because you're going to be doing that. You're going to be seeing the finished result in the labs sections. So what I really want you to just focus on is just the bird's eye view of brain connectivity. So if we have a region that looks like it's kind of like a low negative number, maybe like a, so maybe you can think of it as a less used road, not many cars traveling on it and very infrequently. So we can think of the low values meaning some connection between the regions exists, but they're weaker and less frequently used. And we can think of the high values as a busy highway, lots of cars using it frequently going in both directions. So this could mean, this kind of a higher positive number could mean a strong connection between the two regions and that the signals or information travel between them easily and frequently. Why do these connector matrix values matter? They help scientists understand the brain's wiring and how different areas work together. Low values could explain differences in behaviors or symptoms of certain brain disorders. And high values might support quick communication for complex tasks and language or memory. So did a great job listening to all that information. You now know how to enter the competition on Kaggle. You know what the challenge is about. You know what the task is and what it is you're trying to achieve. Next, we'll take a short break and then move into session 3, where we'll start coding in the notebook with Melanie, and I'm really looking forward to it. And if there are any questions, you can ask them now. Otherwise, I'll hand it back to Dr. Addison. Okay, so we're just about ready to get back in. So I'm gonna stop sharing my screen, and I think Melanie will share hers. So take it away.
Thank you, Leslie Ann. Okay, so we're heading into session 3, which is setting up. I know some of you may haven't gotten the folder, but in the chat, there's a folder with all of your resources. There is the notebook, and we'll be going through the notebook as well after setting up. And most importantly, there is a document called Accessing Google Colab. So what that document details is how to actually get your Colab notebook. So I'm just going to share my screen. So for the beginners, what you would want to do. So first of all, one of the requirements is a Google account. So your Google account is very important because what Google Colab will want you to do is to sign in. So you will need that Google account. Once you have your Google account, you can just search Google Colab. So I would have searched Google Colab, and I'm just going to click on it. And once you sign in, you will see something like this. And then you could just click upload, and you could download the notebook from the folder, the share folder that was shared with you all, and you could upload it this way. So I'm just going to exit here, and I'm going to share my notebook. This was the notebook that was shared with you all. I think I stopped sharing. Right, so could you all see the notebook on my screen?
Yes, we can.
Okay, great. So the way that I explained how to upload a notebook, that is one way you could do it. Another way is that you could click File and Upload Notebook, and it will allow you to upload that notebook that you've downloaded from the drive. So once you have your notebook, my notebook, all my cells are already run. And today we're going to be looking at mastering data analysis. So we're going to look at from data loading to exploratory data analysis, also known as EDA. So as I said, some of the requirements was a Google account, and that is important to access your Google Colab notebook. And as Leslie Ann would have demonstrated how to get your Google account and why it is important, because we need the JSON API key. So that will help us get access to the Women in Data Science dataset. So here we just have a short overview of what we will be doing in this session. So we will be importing the Women in Data Science dataset. Then we'll be loading that data, inspecting, and merging for analysis. Then we move on to the exploratory data analysis, which is the EDA. And within that, we will assess the data quality and do some initial exploration. We will also do univariate analysis. We will explore the target variables. We'll move on to the bivariate analysis. And lastly, we would look at the multivariate analysis. So some advantages of using Google Colab, it's online, and you could share it, as Leslie Ann would have said, with your colleagues, and you all could work on it at the same time, as well as you could access very powerful GPUs. This was really helpful when I was looking at image processing. Sometimes, your computer cannot really do that processing, so Google Colab, you can do the processing there, and it speeds up the processing time. So now we'll just look at some Google Colab basics. So the notebook consists of cells. You have your text cells, and then your code cells. So there are many ways you can get these cells. One of the ways is if you hover in between, you can see plus code and plus text. So your text cell is really for explanation, documentation, or comments to your code. You don't want to just have your code and then you visit it later and like, what is this code? What was I trying to do? So it's always important to comment on your code so when you visit it later, you know what you were doing, and it's very helpful. So the code cell is for writing and executing your Python code. So I'm just going to click plus code. So here within this cell, you could write your Python code, and to execute your Python code, you click on the play button next to it. Within the cell, you will see start coding or generate with AI. So I'm just going to click generate. And what that does, it brings up this prompt. So what I could do, or what Google Colab allows me to do, is to write a prompt. So I'm just going to write print hello world and click enter. And what Google Colab does, it actually gives me the code. So here we have the code print and hello world in it. So what I'm going to do, I'm going to execute this cell by pressing the play button, and it comes up hello world. I mean, this is something that when you're coding any language, this is the first thing that any language teaches you, is how to print hello world. So that is just covering some of the basics. Now we'll move on to actually looking at the Women in Science dataset for 2025. So what this challenge does, it really tasks us with building a multi-outcome model to predict an individual's ADHD diagnosis and sex, using the functional brain imaging data of adolescents and their socio-demographic, emotional, and parenting information. So when I say multi-outcome model, what it is, it's a model that is designed to predict multiple target variables simultaneously using a single machine learning model. So our target variables for this datathon is the ADHD outcome, and 0 means that person does not have ADHD, 1 that person has ADHD, and then as well as the sex, so 0 is male and 1 is female. So that is just a little overview of the datathon for 2025. Also, if you have any questions, feel free to drop them in the chat. My colleagues will be glad to assist you, or you could always stop me and I will be happy to answer them. So first thing that's very important is that we need to import our dataset. So we need to get that dataset from Kaggle into our Google Colab in order to process it. So there are many ways to do that, but most importantly, we need libraries or dependencies. So Google Colab often comes with many popular libraries that's already installed. We have some listed here, such as Python, TensorFlow, PyTorch, but you could actually write some code to import your own libraries. So in this cell here, under accessing the Kaggle dataset, because that is what the first thing we're going to look at, I would have written import Kaggle Hub. So this will install this library, and then I have put in additional code kagglehub.login, and what that allows is that once it's run, you will be able to enter your username and token. So I have a snippet here. And once I've entered my username and token, it tells you, okay, your credentials were successfully validated. So that means you have that connection. For those of you who may now been joining, I would just quickly go over it, but I know Leslie-Ann would have went through it previously. So just a quick overview. So I'll just be switching my tab. Right. So now you should be seeing my Kaggle page. I'm just going on the top right-hand side on my profile icon. I'm going to click on settings, and then if you scroll down or look a little bit lower down, you will see API. You click on create new token. Now a file will download. You could open it using VS Code or Notepad, sorry. And in that, it will have your username and token. So you just copy and you paste it in your Google Colab. And you just click login. So once you have done that, what you want to do is you want to import your Kaggle dataset. So Leslie would have also went through how to get this important piece of code, because that tells Google Colab, okay, this is the dataset that you're looking for in Kaggle. So that is how it knows, okay, so this is the dataset that it's looking for, so that it's going to pull all of those datasets. So once you've run that code, you would see this message, the data source import was complete, and then it shows you the path. So to find the path, if you're interested, on the left-hand side, you see files, and then on the top is your root, and then you go through these folders to look for your data set. So it takes a little bit long to load. So once you have imported your data set, and you could look at your path, and then you want to make sure that you have all of your files that you need. So here I installed more libraries to give me more functions, and then I wanted to list all of my files, so this is the code that I would have used. So here we see that we have the sample submission, and that file is the template showing the required format for the competition submission. We have our data dictionary, which is very important because it contains the description and the definition of all the variables and features in the dataset, and it helps us to understand what are these features, what are they talking about, because sometimes we may not understand just that word that they would have named that variable. So it gives us a more broader understanding. So here we have 4 training files and then 3 testing files. We could see that the quantitative and categorical data were broken up in separate files. So your training data, it's used to build and train your model, and then your testing data is used for model evaluation. And just a little bit of context, your categorical data, so that is like categories or groups. So when I say category or group, some examples could be like letter grades or hair color, because those will be in categories. And then your quantitative data is your numerical data. So this could be continuous. An example is height, or it could be discrete. An example of that is the number of women in a group. So it's a fixed amount, but it's numerical. So we would move on to data loading, inspection, and merging for analysis. So once we have our data set, we want to load it into data frames. So when I say data frames, you're really storing your data into these data frames. So it's easy to manipulate. It is 2-dimensional structures where the data is organized into rows and columns. So previously, I would just scroll up a bit. We would have the parts of all of our files. So this is where it comes in handy because we want to save all these files into data frames. So once we have all of our parts, this here is our data frame. And then we will be reading the file and we'll be storing the information in that file in these data frames. So once I've stored all of this data into my data frames, I wanted to have a little look at what was in these data frames. So to display the first few rows of the data frame, I would have used the head method. So if I just hover over head, Google Colab will automatically give me a little breakdown of the head method, which is great in understanding. So it says here that it returns first n rows. So I would not have put in a number of rows, I just put in head. So it would return the 5 first rows automatically. So here we have participant ID and then all of these columns with numerical values. And this here is the functional connectome dataset. And then I went on to view the rest of the data frames. So I viewed the train data, the categorical data. So our categorical data is in categories. So even though this is numerical, one may have a meaning in it. So that's where our data dictionary comes in handy in telling us what that group 1 means. We have here the participant ID. And then I had a look at the quantitative training data and as well as the task functional connectome. I use head for all of these. And you would see, so it's displaying the first 5 rows and how many columns it's displaying as well. It tells you that information. So I would have viewed all of my data sets and then I would have viewed the target variable data frame. So I could see participant ID, the ADHD outcome. So I see ones here, but there are zeros as well, and we could see the variation for the sex column. And then I viewed the submission file. So this is how your submission file would have to look with the participant ID, the ADHD outcome, and the sex. So from analyzing and exploring, what I did, I wanted to merge all of my training datasets for a complete overview of all the features. So an important thing to note is that when you're merging your data frames, I would have merged all using participant ID. So because the participant ID is unique, there is no participant with the same ID. And it ensures that the data from the various files, so we have 4 different training files, that it corresponds to the same individual and entity across the data sets. So because it was 4 data frames that I have, I would have merged the quantitative and categorical data first using the participant ID. And then once I've merged that, I named it as combined data 1. And I merged that with the functional connectome. And then I would have merged the target variable with those, and I call it combined data. So once I've combined all of those data, I viewed it, just the first 5 rows. And this is to just give you an overview of it. So you have your participant ID, HQ total. So you can see that is the score, your color vision, and then all of these here as well. So you can see how many rows that we're just viewing, but it lists out all of the columns. So here I would have went on to just have all of the columns listed here and what it means. But if you need more information, you can definitely look at the data dictionary. And then our target
here,
here.
Malini, just to ask, anybody has any questions for Malini? If you have any questions, feel free to stop us and let us know.
Yes, please do. Okay, so if there are no questions, I will just continue, but please let me know if you have any questions. So these here are target variables. Even though I would have just viewed the 5 first rows, I wanted to know the shape of that data frame combined data. What I mean by shape, the number of rows and the number of columns. So we could see here that there is 1,213 rows, and then there is a large number of columns. So I went on afterwards, when I've combined the trained data set, I wanted to merge the test data set. So when you're exploring your data, you could explore your training data set, and you can also explore your test data set as well. So I followed a similar concept where I merged on the participant ID. For the test data set, there were 3 training data frames. So we had the quantitative data and the categorical data. So we would have merged those two, and then I merged the functional connector. So I just viewed my data, and then I wanted to see how many rows and how many columns. So when I ran the shape method, there's 304 rows, and if you look at it here and the previous shape, you realize that there's 2 less columns. The reason for that is because the target variables are not in the test dataset. In the test dataset, you want to use your model to predict the target variables. So that's why it's not in the test dataset. So now I'll move on to the EDA. And the EDA really helps us understand the dataset and identify patterns, see what data is missing, and let us have a look at the outliers. So we're just going to assess the data quality and do some initial exploration. So here I would have used a method called info. So this is just to give me a little bit of information about the dataset, like the number of columns, the type of data that was in the data frame, and how much memory usage is for this data set. So it just gives me a little short overview of that data set. And then what I went on to do, I wanted to check if the unique values in the target variable for the ADHD outcome and the sex. This was just to ensure that, I didn't have to do any data cleaning. So once I run the code for the unique values, I saw there's only 0 and 1, which is good. I didn't have to do any data cleaning. And then I went on to look at the counts, how many people had ADHD and how many people did not have ADHD. So for the number of people that had ADHD was 831, and the number of people who did not have ADHD was 382. And similarly, this was done for sex. So we only have 2 values, 1 and 0. 1 is female, 0 is males. Here we could see that.
Sorry for the interruption, Melanie. Someone is just asking if this is confirming that this is for the test data set.
Yes, this is for the test. No, this is for the trained data set. For the test data set, we don't have the target variables in that data set. The reason why we don't have the target variables in the test data set is because we're trying to predict those target variables. So we only have it in the trained data set. I hope that's clear.
Yes, the person said, okay, thanks.
Okay, great. So for the sex, we have two unique values, 1 and 0, so we don't need any data cleaning. 1 is for females, 0 is for males. We see that we have 797 males, and for females, we have 460. So what does this output tell us? So for the ADHD, we can see that it's slightly imbalanced because we have more cases of persons with ADHD. So this might affect our model, and it might require some techniques like resampling and weighting in order to balance the data. And then for females, because we have 797 males, so we have more males than females. So this also leads to gender imbalance in the data set. And this could introduce some biasness in the modeling. So this would be looked at in the data modeling and in terms of how we balance the data set. Next, we look at the missing values. So we would have looked for the missing values in the training data set because we're using combined data. So combined data merged all of our training data sets into this one data frame. So we looked at the missing values in this data frame. So we could see that only 2 columns have missing data, and that is the MIR track age at scan, which has 360 missing data, and then the ethnicity has 11 missing data, and the type of missing data is integer. So this was done for the training data set, all of the training data set. So another thing we can do is look at the summary statistics of only the numerical features in the training data frame. And how we would do that is that we would use the method describe. So once we run that method describe, the output that we get is the count. So here for the column EHQ total, we have the count, and that count tells us the number of non-null values in this particular column. Then we have the mean, which is the average of the values in this column, and the STD, which is the standard deviation of the values in the EHQ total column. So minimum is the minimum value within this column, and we could see that we have negative numbers with the minimum being minus 100. So that is very interesting. Then we have the 25, 50%, and 75% quartiles. So the 25% is where 25% of the data falls within that quartile. And then the 75% represents the value below which 75% of the data falls. And the 50% is the median, is the middle value of the data set, where half of the data falls below or half above it, and that normally indicates central tendency. And we have our maximum value in this column, which is 100. So this tells us that our maximum value is 100. So we have this readout, this summary for all of our numerical features in the training data set. And remember, we would have merged all of our training data set, which was like 4 files, into the combined data. So it gives us that readout for combined data. Are there any questions? Okay, so I will move on. Sometimes we may want to just look at one column in particular. So the column that I'm interested in looking at is the MIR track age at scan. The reason being because there were some null values in that column. And I'm looking at this column in the combined data where I have all of my training data sets. And here we could actually see the null values. And then we have the integer values as well. And there we have the type, which is float, because it's decimals. So here I have a short write-up on how to interpret plots. So the histogram and box plot, we'll be looking at that, as well as I have a list of pretty fine MATLAB styles. And what this really could help you is with the appearance of like your plots, such as the color, the grid, the font, for really better visualization. So you could just make it look pretty.
Sorry for the interruption. Someone is asking if prior knowledge is required. Prior knowledge of Python is required to participate.
So I think with the some of it, yes, but you could always use Gemini, which I would have demonstrated earlier, and ask it to help you with some of your code. Sometimes it's not always correct. You may need some debugging and fine tuning.
There's another question as well. How did you know the MRI track age at scan had null values?
Okay, that's a good question. So I'm just going to scroll back up. And here, so this would have been under the section access quality data and initial exploration. Here, I checked for missing values. So what I did, I have a new data frame and I use the code. So combined data is the data frame that has all of my training data. And I'm using the method is null to see, to really, and the sum method as well, to count the null values in all of the columns for the combined data. And then what I'm going to do, I'm just going to print only the columns that have missing data. I'm not going to print all of the columns. So that's what this code does. And then once I run it, the output looks like this. So this is how I'm able to know that the MIR track age at scan has 360 missing values.
Yes, the person understands now.
Okay, great. Are there any other questions before I move on?
No questions in the chat right now.
Okay, thank you. So we're going to move on to look at the univariate analysis. So when we say univariate analysis, we're really looking at the distribution of a single variable, so just of one feature. And to do that, so I would have installed some libraries, matplotlib. Something interesting here that I should point out is that while I might have the library Seaborn that I'm importing, this as here, it means I'm going to refer the Seaborn library as SNS. So I'm giving it an alias. So throughout my code, instead of writing Seaborn, I would just write SNS. So it's a little bit, I'll say just more easy to write in my code. So you might see like plot within the code instead of like matplotlib. So here we could see that I'm calling that library. So here I would have the code for the visualization. Since there were so many columns, we did a for loop. So within this for loop, we have the distribution plot, we have the box plot, and then we have some statistics for that feature. I would have sectioned the continuous and categorical values. And the reason for doing that is just to facilitate the appropriate analysis and the modeling technique for each. So I would have plotted the graphs. So we'll just have a look at the first one, which is the distribution of the EHQ total. And the EHQ total is really a numerical representation of the hand preference. So if you're like left hand or right hand, that is what that number tells you. And if you remember previously, when we were looking at the summary statistic, we saw that the minimum was 100 and the maximum, well, the minimum was minus 100 and the maximum was 100. So we could see that as well in this graph. Also, we could see that the graph is a little bit skewed to the left. So when I say it's skewed to the left, what that means is the tail of the distribution extends towards the left-hand side, and the bulk of the data, it's more concentrated on the right. So that's when I when I say skewed to the left. So here we have our box plot. So we can see like it's not on the 75 mark, but it is a little bit above. And so that kind of suggests that most values are higher. And then there are many negative outliers. We could see that here from the whisker, the dots below the whisker. And then we have our summary statistics. So we have the mean as 58.88. And then the median, which is 76.67. So it's a little bit above the 75. And it's higher than the mean. Then we have the standard deviation, which is 49.86. And that indicates that there's a high variability. And then the skewness is minus 1.62. So it's negatively skewed because of the extreme lower values, the negative values. So that is just how we interpret the distribution, the box plot, and the summary statistic. So now we want to explore our target variables. So here's the code for the graphs that we would output here. So I have a distribution of the ADHD diagnosis. So we could see here that the majority of the individuals in the dataset have been diagnosed with ADHD. Here we have a distribution of the sex, and we can see here clearly that there's more males than females in the dataset. And we have another bar chart, and this shows us the ADHD diagnosis distribution categorized by sex. So we could see here that the ADHD diagnosis is more prevalent in males compared to females. However, because of the distribution of the males and females, it could impact the analysis because it could lead to bias modeling. So this will be addressed in the data modeling section. So this gives us a bit of overview of our target variables. Next, we will move on to bivariate analysis. So when I say bivariate analysis, it means a relationship between two variables. So when we're looking at the bivariate analysis, we also look at the t-test statistic, and that tells us how different those two groups are because we're going to be looking at two different features or variables. And the higher the t-statistics means that the groups are more different. So the t-statistic above +2 or below -2 is often considered high, indicating a strong difference between the group. Another feature, feature that we'll be looking at is a p-value. So a low p-value is less than 0.05, and what this suggests is a significant difference between the groups. A high p-value is more than 0.05, and this suggests no significant difference. So both of these help determine if a feature is statistically associated with the target variable. So here we have the feature EHQ total, and we have the box plot, and we're looking at it compared to the ADHD outcome. So the people who have ADHD and people who do not have ADHD, as well as we have our test statistic and our p-value. So here we could see that the box plot on the right, its median is a little bit higher than the one on the left. And as well as we could see our outliers here, that is the dots beyond the whiskers. So our t statistics here is minus 0.60. So what this suggests is that there is a minor or weak difference between the groups. And since the value is close to 0, there is little to no significance. So the p-value is 0.5493, and it's greater than 0.05. So this means that there is no statistically significant difference in the EHQ total score between the ADHD and the non-ADHD group. So the EHQ is not statistically associated with the ADHD. I know that was a little bit to take in, but I hope that everyone understands. And if you don't, you could always drop your question in the chat. So lastly, we'll be looking at multivariate analysis. So we'll be only looking at the numerical columns in the data frame before computing the correlation matrix. So that's what we're going to look at, is the correlation matrix. And here we have our correlation matrix. And this correlation matrix helps us identify the relationship between the features in the data set. So it's important to look at the relationship because you only want the features that have a strong relationship when we're doing the machine learning part, because that will influence our accuracy. We don't want those that doesn't have a relationship with our target variables, because that will just give us bad accuracy. So that is why it's important to look at the relationship between these variables. So on the right here, we have a bit of a legend. So we could see that 0 is more like blue, but as you go higher, 1, which means that there is a strong correlation. And if it's -1, closer to -1, there's a weaker correlation, because we could see some of the values here are negative. So we definitely want those that are more reddish orange color. Leziane would have spoken this in her presentation about why all is one diagonally. So we can see here that we have a lot that is strongly correlated, but it's definitely a lot to look at. So if we scroll down, we have a correlation with the target variable, and we could see here which one have a more stronger correlation. So these one here above 0 is the ones that we could take in consideration when building our model. And this really brings us to the end of the notebook. And I would really like to thank Nicholas Smith and Leziane for also contributing greatly to this notebook. So if you all have any questions, you all can ask, but I will let Dr. Addison take over from here.
Thank you so much, Melini. Very, very comprehensive presentation. I think we have two questions in the chat. One is from Sana Gabriel. She mentioned, can you go over the T statistic and p-value explanation again?
Yeah, sure. I'll just share my screen. And we can. Okay, so here we have the t statistic and the p-value. So with the t statistic, if it's closer to 0, that means it's a weak difference. So those are the features that we might not want to consider. So this one here is minus 0.60. So it's far from minus 2 or plus 2. It's closer to 0, so it's a weak statistic. And then we have our p-value. So our p-value is 0.5493. And we could see that it's greater. So I'm just going to, okay, can't really highlight it, but this line here, so it's a high p-value because it's greater than 0.05. So this suggests that there is no significant difference. So I hope that you understand the t statistic and the p-value a little better now.
And just to add to what Melini is saying, so you could just get a visual from basic statistics in terms of what that means is that, like how she said, you have groups. So a lot of the times when you want to think about if the group has significant differences, you want to probably use what we call a test statistic. So the t value, and there are also z and others, right? Those actually represent a value that could tell you whether the differences appear to be significant, and then you could see what other tests you could use or predictions you could make. But it's really to have a gauge. So I don't know if that's helpful. And I know Melini explained it very well. So let us know in the chat. And I think there was another question. The t statistic, understood, yes. Yeah, and there's a p-value that corresponds to that. And for those of you who may not be as familiar as well, those are just metrics to help you in the exploratory phase to know if you need to go further and do investigations. I think Matthew asked a question, and I believe Nicholas also answered, but just Melini, for your benefit, it was based on the variables, for everybody's benefit. 19,000 columns in the data. So I thought there would have been 19,000 variables, but the correlation matrix just has a few variables. And
Oh, yes.
yeah.
Yeah, so I think Nicholas would have answered that, but just to iterate. So I actually kept all of the variables, and it was just running for a very long time and failing because it was just so many columns. So I had to drop those connective columns and just do the categorical and quantitative in order to get the matrix.
So just to add on that for Matthew, you can plot as many correlation matrices as you want and just continuously subset it, as in the first two, EHQ and color vision. In this plot here, you have it, but the next one you want to plot, you can remove that and add in two more. So you can just continuously do that. Since it has so much columns, this would be one of the ways to go about it. If you want to know which columns you would want to keep, if you scroll down, Melini, this display here with the correlation to the target variable, you can use this to decide which ones you would want to keep in your next plot you want to display. Or from the analysis from before, the bivariate or multivariate or no, univariate analysis, you can use that to help you decide which columns you want to keep or not. Okay.
Thank you, Nicholas. Are there any more questions? Okay, so I'll just stop sharing.
Thank you very much to our speakers. To the audience, okay, is someone talking? No? Okay. We have a feedback form in the chat. So please feel free to fill out our feedback form with any of your comments or your questions. And I would really like to thank the speakers we had today. Leslie Ann, who went through the initial session to give you all a really nice overview and outline of all the different steps and the different meanings of the content of this challenge. And of course, Malini, who went through the notebook. I know some of this may be a bit high level and a little bit faster in pace because of the time frame that we have. But for any of you who need more in-depth insights into the notebook, we are always happy to help. So you could feel free to reach out to us directly. Hadia will put our Gmail address in the group. I think I also mentioned it before, widsttgroup@gmail.com. And also you can visit our website to see when we have our other upcoming workshops. And of course, I cannot forget to thank also Nicholas, who has been a very huge part of the notebook process, and he can answer a lot more the technical questions for any of you who are more advanced. So this is the end of today's session. We would like to thank you all very much for attending. And don't forget, we will send the recording via email. We will also post it on YouTube, so you all could subscribe for our YouTube videos. There are also some more beginner level videos based on using Python and other programs that some of you may be using for analysis. And we have our next session next week, Saturday, at the same time from 11 a.m. AST to 1 p.m. So we're looking forward to you all joining us as well. And that's it from me and the team. So we would look forward to seeing you all in the next one. So thank you again, everyone, and have a great morning, evening, afternoon, night, wherever you are in the world. Take care and see you soon.